Let's have a look at our equations. Heat transfer, specifically equation 33. Now this is the equation for conduction. Heat transfer via conduction through a material. Conduction through a material. And the equation states, I'll just simply rewrite that equation on this sheet. Q is equal to Ka delta T. And I place those in brackets only to isolate the little t. And I'll show you that in another video, divided by L. Let's have a look at these variables now individually. Q, that is heat. I call it heat energy because it has the unit of a joule. Little letter K, that is thermal conductivity. Conductivity, and it has the units of joule per seconds, meters, and Celsius degree. Thermal conductivity is a constant. Different materials will have a different thermal conductivity, and it's simply found in a chart like this one. Here's one for thermal conductivities in joules per seconds, meters, Celsius degree. Aluminum would be a value of 240, and on down the list. Gases and other materials. The letter A, this is the cross-section area, this cross-sectional area. If we had a bar, and that bar was, say, rectangular in shape, and it has some length to it, the cross-sectional area would be this area right here. If that bar were circular, the cross-sectional area, then if we were to cut through that bar, of course we're going to find a circle, another piece like this one, and the area of a circle, as you all know, is pi r squared. Next one here, this is delta T. And delta means a change in something. Change in our case, it is temperature. Capital T represents temperature, and the unit of temperature is the Kelvin. Change in temperature. Little t represents time in seconds. Down here, the capital letter L. L is a distance. That distance could be the length of that particular object, length, or it can be the thickness, or it can be the width. All depends on the distance that the heat needs to travel through. For instance, consider a window. Here's a window, and it's hot outside and it's cool inside. Speaking of the summertime, heat always travels from a place that's hot to a place that's cold. So I was going to travel this way, and L is the distance or the length that the heat must travel through. This would be L. If it were a bar, and the bar has some distance to it, and I will heat up this end right here. I'm going to draw a little flame in order to show this part here as being hot. Heat will travel from a place that's hot to a place that's cold, and L then would represent, well, the length of this bar. The distance that the heat needs to travel through from where it's hot to where it's cold. Now, I'll be represented by the letter L. And it can be a length, a thickness, or a width, depending on the geometry of the item. And of course, all distance has the unit of a meter. Take this another step, this equation. I'm going to rewrite it here on the opposite side. Q is equal to Ka delta T times little t time and L. I would like to take K, the thermal conductivity constant, and put it in the denominator. In order to do that, I need to multiply the numerator times 1 over K. And whatever I do to the numerator, I must also do to the denominator times 1 over K. This effectively, I'm just multiplying by 1. 1 divided by that effectively gives me just 1. So I haven't really changed the equation any. However, in the numerator, the 2 K's cancel out. And this will look like Q is equal to A delta T times the time divided by L divided by K. This term right here, L divided by K, has a special name. This is the R value of specific materials. Different materials will have different R values. R values represents how much heat is lost through that material. A high R value means less heat loss. And the low R value means more heat will travel through that material. Consider, I have here a booklet from the Natural Resources of Canada, and that explains on what individuals can do with their homes in order to prevent heat loss. Here is some insulation being put in a wall. An insulation has R values attached to them. The higher that R value, the greater the insulation value of that particular item. And here is various different a list of nominal R values. The higher the R value, the better the insulation properties, and the less the R value, the greater the heat loss through that particular material. Going on through to the next one. Different ways to insulate your home. Insulation in the ceilings or in the walls, either in the inside of the walls or the outside of the walls or in the attic. And all these various materials all have an R value. And if you even look at windows, here is a window. Windows also have R values, and heat is lost through windows. Here's another window. One way to retain heat in the home and stop it from going through a window or minimize it is to put curtains in front of a window. That will effectively increase the total R value of that window, including the curtain. This entire book can be explained, the various items that are going in it with this equation right here.